In the name of Allah. In this lecture, we will talk about the shield wire, or earth wire, or ground wire, which is located at the highest point on the towers of overhead transmission lines and extends along the length of the overhead transmission line. We will learn together why some towers or some overhead transmission lines have only one earth wire installed, while other towers or overhead transmission lines have two earth wires. The second important topic is that we will understand the difference between the traditional earth wire and the optical ground wire, OPGW. We will also examine whether the earth wire's function is really limited to protecting the overhead line and insulators from lightning strikes only, or if there are other functions as well. I have previously mentioned that one of the main components or accessories of the overhead transmission line is the shield wire, earth wire, or ground wire, which is usually made of galvanized steel. I also mentioned that the earth wire is installed and positioned at the highest point on the tower of the overhead transmission line and extends along the entire length of the transmission line. Of course, we stated that the primary and fundamental function of the earth wire is to protect the overhead transmission line and the insulators installed on it from the danger of lightning strikes. For the earth wire to be able to safely discharge the lightning strike, it must be properly grounded. Therefore, it is necessary to know that the tower body or the tower legs at the base are grounded using earth conductors or earth rods or a well-established grounding grid. From this, we understand that the earth conductor located at the highest point of the tower is well connected to the metallic body of the tower, and the tower body is connected at the base or grounded with a good grounding grid. Consequently, this ensures the easy and rapid discharge of any lightning strike to the ground. But we must know that there are two types of earth wires or earth conductors used in overhead transmission lines. The first type is the traditional type, which consists of a conductor or wires made of galvanized steel. As we mentioned before, its primary function is to protect the transmission line and the insulators from lightning strikes. The second type consists of a conductor or wires made of galvanized steel with an optical fiber cable inside, known as the optical ground wire, OPGW. Now, what is the importance or function of the second type, which is the optical ground wire, OPGW? Of course, its primary function is grounding and protection from lightning strikes because it contains steel wires. The second function, which distinguishes it from the traditional earth conductors, is the transmission of information and the communication system between different substations and control centers because it contains an optical fiber cable. We have generally understood together the importance of earth conductors or shield wires, whether of the traditional type or the optical ground wire, OPGW type. However, we want to understand in more detailed terms the importance and function of the earth conductor or shield wire located at the top of the overhead transmission line towers. The first function of the earth conductor, shield wire, or ground wire is to protect the phase conductors and also the insulators of the overhead line from direct exposure to lightning strikes. Naturally, the earth conductor or shield wire receives the lightning strike because it is the highest point on the overhead transmission line and works to divert and discharge this lightning strike to the ground through the grounded metallic tower structure. The second function is that the earth conductor, shield wire, or ground wire provides low impedance paths, meaning easy paths for earth fault currents. But how does this happen? Of course, we all know that the earth conductor, shield wire, or ground wire is connected to the highest point of the transmission line tower and to the metallic structure of the tower. The second thing is that the earth conductor extends along the entire length of the transmission line, meaning it is connected to all the towers at the top. The third thing is that all the towers are grounded from the bottom. We all know that the earth itself acts as a conductor, so we understand from this that all the towers are connected to each other from below through the grounding and the earth. Consequently, we understand that the earth at the bottom and the earth conductor, shield wire or earth wire or ground wire at the top make all the transmission line towers connected in parallel with each other. Of course, as I mentioned earlier, the The lightning current or earth fault currents are discharged to the earth through the metallic structure of the tower. Therefore, the paths for these currents are the metallic tower structure itself. The metallic tower structure has resistance or impedance, and we all know that when resistances or impedances are connected in parallel, the total equivalent resistance or impedance decreases. Hence, we understand that the resistance or impedance of the tower structure will decrease as long as all the towers are connected in parallel. This, of course, will provide an easy path for earth fault currents. As we can see in front of us, the earth fault currents are distributed among the adjacent towers. Therefore, we understand from this that the presence or importance of the shield wire or earth wire or ground wire is that it provides a low impedance path for earth fault currents and lightning currents. The second point is that it helps in distributing the earth fault currents and the currents resulting from lightning strikes over the adjacent towers. The third point, according to what we have said, is that all of this results in better operation and higher efficiency of the protection devices. Also, one of the functions and importance of the shield wire or earth wire or ground wire is that it reduces as much as possible the electrical interference or electromagnetic interference between the parallel transmission lines. Of course, we all know that each transmission line has a certain voltage, electrical power, and electrical current. This means that each transmission line has its own electric field and magnetic field different from the others. Naturally, there will be interference between these fields, and that is why the shield wire or earth wire or ground wire somewhat reduces this electromagnetic interference. The fourth function of the shield wire or earth wire or ground wire is to reduce electrical stresses, meaning the stresses caused by voltage and electrical current on the earthing system of the substation located at the end of the transmission line. Based on the same concept mentioned in point number 2, we find that the shield wire or earth wire or ground wire acts as a parallel path to the earthing system of the substation. Since the shield wire or earth wire or ground wire is connected in parallel with the earthing system of the substation, this means that a portion of the earth fault current occurring inside the substation will pass through the shield wire. Consequently, the earth fault currents inside the substation will somewhat decrease. As these currents decrease, it means that any electrical stresses, whether voltage or current, caused by earth fault currents will also decrease within the substation. The fifth function of the shield wire or earth wire or ground wire, as I mentioned earlier, is that if the earth wire is of the optical ground wire, OPGW type, it will be used for data transmission, control signals, communications, and protection related to the transmission line, as well as between different substations and control centers. Next, we come to the last point, which is that sometimes we find that some overhead transmission lines have only one earth wire installed, while other overhead transmission lines have two earth wires. So why are there two earth wires in some cases and only one in others, and what is the difference between them? As I mentioned earlier, the primary function of the shield wire or earth wire or ground wire is to protect the phase conductors and the insulators of the overhead line or the tower insulators of the transmission line from lightning strikes. But we must understand that the earth wire or shield wire or ground wire protects a specific area, or in other words, the earth wire has a certain protection angle. Therefore, if a lightning strike hits the earth wire, it can protect the phase conductors R, S, T, and the tower insulators located within this protection angle. However, if these insulators or phase conductors are located outside the protection angle, it means that this earth wire cannot protect them. According to some research and specialized companies manufacturing transmission towers, the protection angle of the earth wire or shield wire or ground wire, for example, the angle theta shown here, is as follows. For transmission voltages up to 132 kilovolts, the protection angle should be less than 30 degrees. For transmission voltages from 132 kilovolts up to 230 kilovolts, the protection angle should be less than 20 degrees. For voltages higher than 230 kilovolts, the protection angle should be less than 10 degrees. To better understand the concept of the protection angle or protection zone, and the reason for having either one earth wire or two earth wires on some overhead transmission lines. Let us consider, for example, a transmission tower for a certain electric voltage. In the image before us, there is one earth wire located at the highest point of the tower and extending along the length of the overhead transmission line. Let us assume, for example, that the protection angle for this overhead tower is 30 degrees. This means 30 degrees to the right and 30 degrees to the left. It is important to know that to achieve this 30-degree protection angle, the earth wire, also called the shield wire or ground wire, must be installed at a certain height, as clearly shown in the image before us. From this, we understand that all the conductors, phases, or insulators located below the red lines are within or inside the protection zone. Or more precisely, as we see in front of us, the protection zone safeguards all the insulators and conductors of the tower before us. Therefore, if a lightning strike hits this line or this specific tower, we will notice that the earth wire, also called the shield wire or ground wire, is able to protect all the conductors and insulators, as clearly shown in the image before us. So, we have understood that this tower is designed for a certain voltage level, and the earth wire, also called shield wire or ground wire, is installed at a specific height, thus providing a certain protection angle. Let us assume that the tower in front of us has the same voltage level as the previous tower, but it was designed for certain technical reasons requiring, for example, a specific horizontal spacing between the phase conductors. Suppose the earth wire, also called shield wire or ground wire, is installed at the same height as before, and since the height is the same, the protection angle remains the same. However, we will notice that the protection zone has changed because the width of the tower has increased, or in other words, the horizontal distances and spacing between the phase conductors have increased. Therefore, we can understand from this that unfortunately, the protection zone does not cover or protect all the insulators or conductors of the tower. As we can see, the insulators of the phase conductors R and S, whether for the first circuit or the second circuit, are located outside the protection zone. This, of course, means that if a lightning strike hits this tower, it could very easily damage the insulators of phases R and S for both circuits. So we want to know what is the solution to this problem. As long as we are constrained by the same protection angle, the solution is to raise the shield wire or earth wire or ground wire to a higher elevation than the previous height. This is necessary in order to achieve a protection angle or protection zone that is capable of covering or protecting all the insulators on the overhead transmission line. Indeed, by increasing the height of the shield wire or earth wire or ground wire, we were able to achieve a protection zone that successfully covers and protects all the insulators of the overhead transmission line. This means that as the width of the tower increases and the horizontal distance between the phase conductors increases, should we always increase the height of the shield wire or earth wire or ground wire? Of course not, because this would imply that for transmission voltages such as 500 kilovolts, the height of the shield wire or earth wire or ground wire might need to be as high as the tower itself, an impractical solution that would result in extremely high construction and economic costs. Therefore, the only practical and feasible solution for towers operating at 500 kilovolts, for example, or for towers with large horizontal spacing or separation between phase conductors, is to use two shield wires or earth wires or ground wires as clearly shown in the image in front of us. In this configuration, each shield wire or earth wire or ground wire is responsible for protecting a specific area, let's say half of the tower. For instance, the first shield wire or earth wire or ground wire protects the insulators of phase conductors R and S, while the second shield wire or earth wire or ground wire protects the insulators of phase conductors S and T. This solution is much more economically efficient and practical compared to using a single shield wire or earth wire or ground wire at a very high elevation. In the images in front of us, we see an example of the use of two shield wires or earth wires or ground wires, and of course this is due to the large horizontal distances or horizontal separation between the phase conductors. Therefore, it is essential to understand and know the basis on which the number of shield wires or earth wires or ground wires is selected. Why, in some overhead transmission lines, only one shield wire or earth wire or ground wire is used, while in other lines, two shield wires or earth wires or ground wires are installed. Thank you for your attention. See you in the next lecture.